Yeah, thank you for having me. Okay, let's repeat it again. Today I will present our work on bioschemas and NFD4Biodiversity and focusing specifically on what we have already achieved, but also where important mapping gaps still remain and what things are still missing. This is also a short report on technical deliverables, some unresolved issues, and possible next steps. I will first outline the motivation and the progress we made, and then show concrete mapping examples, and finally discuss the gaps, also propose priorities and open technical challenges. I would also suggest to keep the questions until the end, so I can first give you a full picture, and then we can discuss everything. Okay. Yeah, how did we start? Within the consortium, NFD4Biodiversity Bioschemas has already been endorsed through forming a bioschemas implementation interest group, which was composed of institutions that either have already adopted or strongly aim at integrating bioschemas. Within its harvesting and search infrastructure, it is seen as a potential replacement of an older internal XML format. The group was also reflected in a specific white paper we published in F1000 Research in 2025, which basically documents this work and depicts the necessary steps for the full adoption of bioschemas, and also describes the ecosystem components and their bioschemas compatibility and how this can be obtained. Also, in this white paper, we assess the standards pros and cons to advertise it within the community. From a technical side, we have already produced ABCD 2.62 bioschemas mappings for a specific dataset search use case, while mappings to BioSample and Taxon types are currently in progress or finalized but not implemented yet. In parallel, we enhanced the data transformation service, or in short DTS, that is able to generate bioschemas, JSON-LDs, using a combination of XSLT and Python scripts. This is really important because it turns existing biodiversity metadata into bioschemas for the GFBio search and harvesting infrastructure, which can be seen in this figure. And one important point to note is that early adopters are already publishing server-side schema.org or bioschemas JSON-LD, including Bexis2, DSMZ, and SNSB. Also, the DTS is not just a conceptual prototype. It already converts other formats to each other. For example, ABCD to Darwin Core, Darwin Core to ABCD, and it is intended as an infrastructure component for downstream use. Yes, then I will proceed with the next slide. Basically, our mapping approach follows the bioschemas marginality approach, meaning we paid close attention to what is minimum, recommended, and optional. For the use case of dataset search, we aggregate information where or that improves discoverability. For example, identifiers, taxa, localities, measurements, and people. At the same time, we try to reuse existing properties whenever possible, and we only rely on additional property as a temporary workaround where no better option exists. Another principle is to preserve reversibility where feasible by keeping one-to-one mappings, even though reversibility is not always a top priority, like in the dataset search use case. For record landing pages, the overall goal shifts slightly towards completeness, because those pages should capture richer details than a search-oriented summary. So in short, the mapping strategy tries to balance between use case specific expectations, discoverability, and also semantic precision. For the first use case, this is a screenshot of a transformed Darwin Core XML in bioschemas. For this dataset search use case, here you can see the DCT conforms to property points to the specific bioschemas dataset profile, and the about property contains the biosamples and the taxa that the biosample species belong to. A specific search engine can thus browse through a comparatively flat dataset object, for example, to find any dataset containing a given species or family. The modeled mapping was also published in the form of Zenodo records showing mapped properties, which are linked here on the left-hand side. And these records show mapped properties, marginality, but also missing counterparts in bioschemas for the given ABCD standard. A different use case is the biosample mapping. This revolves basically around mapping ABCD unit level information to biosample. And the key idea behind this representation is that unit level ABCD elements can be reorganized into a bioschemas element graph, where the edges here link to the respective ABCD element. So for example, ABCD biotope or owner. This ABCD-based specimen information, like identifiers, collector, custodian, but also location information, date information, or the taxonomic range, can be successfully associated with properties of the biosample type. This figure, I think this figure also illustrates that the vast majority can already be translated into biosample properties, but at the same time, it shows that the complexity, this graph complexity shows that the modeling becomes difficult, especially specific decisions, and especially when specific groups of ABCD concepts have to be condensed or redistributed across bioschemas properties. So as a spontaneous example, if you have location information in ABCD and then you have to distribute it to completely different properties of the biosample object. In this second figure of the same use case, you can see the taxonomic side of the mapping, of our mapping model. Here we move from the biosample to the taxon, and the taxon name related structures, showing how scientific names, ranks, authorship, and related naming elements can be mapped to the taxonomic range property of the biosample type from the previous slide. In particular, or the red question marks, you may wonder what they mean. These are intentional. They point to areas where the current bioschemas and schema.org structures do not yet fully capture or support the richness of ABCD information. In particular, as an example, the parent taxon semantics are not always sufficient for the relationships that are to be mapped, because parent taxon shows or means that it points to a direct or immediate parent and not what the subordinate taxon. And here's the problem that in our mapping in the ABCD, there is not such a direct relationship, but only hierarchies, and this makes it a bit difficult to map this information into bioschemas. And another gap are some naming related details. Here you can see on the right hand side. So this slide is both a proof of the progress we made and the visual transition toward the limitations that come next. This slide summarizes these major gaps we encountered. One central limitation is the absence of a proper sampling or observation event, which has so far pushed the work more toward preserved specimens than toward observations. Beyond that, several specific elements are still missing or insufficiently covered. For example, identification-related information, here especially the determiner, which is the person who identified a specific species, but also determination history is really, it's currently impossible to map to bioschemas. Another example are some media object properties like image resolution, but also measurement semantics, like the person who made or who did this specific measurement, like we could call this property maybe measured by. And another problem is that IDs for taxons do not always meet condition in the origin data, because sometimes you don't have an ID for a specific taxon, and then it's really difficult to decide which ID you could use for this scientific name. And other gaps are, for example, copyright information, disclaimer information, acknowledgement, and IPR declarations. Based on these gaps, we have identified a small set of bioschemas items that should be prioritized for proposal or community discussion. First, identification should ideally be represented as a specific type of observation with additional properties such as measured by for this determiner information I mentioned before, and identification results for both current and past identifications. A second field would be for media objects, especially images. There is a need for properties such as equipment and the mentioned resolution, and also an extension of the parent taxon definition would be good to ease the modeling, the mapping of ABCD information to bioschemas. But I know this was also or has also been a discussion within the community GitHub, but which is really interesting and shows that there is something moving. To close, I want to highlight the remaining technical and organizational challenges. Even though the work of the Bioschemas Implementation Interest Group came to an unexpectedly early end due to program changes, these points should point out in case the work is to be continued. So far, the transformation work has focused on a single source format, namely ABCD, which needs testing. But we also still lack enough example landing pages and production experience to validate that this approach works under realistic deployment conditions. Another challenge is harmonization, which was described a little too short in this presentation, but this is really important to harmonize interpretations of elements and how we are mapping them with other consortium partners. Even with mappings in place, providers need consistent implementation guidance. So this is really clear. We also see value in the triple SOM as a machine readable way to document mappings more systematically, because currently we just have documented them in a tabular form. And finally, for the missing elements I discussed earlier, there are still no published formal proposals from our side. So moving forward will require coordination with the whole bioschemas community at best. Yeah, one practical next step could be to provide examples generated by the data transformation service as a foundation or seed material for shared test sets and discussion. Yeah, and that's the end of my presentation. If you are interested in the work of NFD4Biodiversity, I would recommend you to visit this webpage. And if you would like to get in touch about the work of the bioschemas implementation interest group, I would suggest to contact one of this or all three persons here. And yeah, I would say thank you. Thanks for having me. And yeah, I'm curious what questions will follow.